Okay, we have here today another integral. This one here is from the Berkeley Math Tournament 2023, tiebreaker number 2. We have the integral from 0 to 1 of x squared over 1 plus square root 1 minus x squared dx. Okay, I actually know two pretty good ways to do this one. I think I'm going to do both. The first thing I want to notice is this is kind of set up for a trig substitution. Just looking at this piece right here, this would be a good trig substitution doing x equal the sine of t. Now, it's not clear how it's going to work with everything, but let's give that a try. So coming over here, I'm going to just set my x equal to sine of t, take a derivative, then dx is just cosine t dt. Now I can rearrange this equation just getting a value for t, taking arcsine on both sides. So then we'll go ahead and substitute. First, let's update our bounds on this thing. So evaluating 1, arcsine at 1, that's going to happen at pi over 2. Then arcsine at 0 is just 0. X squared is going to become sine squared t. Let's do our dx is going to be cosine t dt. Then doing the denominator, we have 1 plus square root 1 minus sine squared of t. But for this here, let's use the identity on this. This 1 minus sine squared is the same thing as cosine squared t. We're inside the square root. Taking the square root of this, we get absolute value cosine t, but we can just drop absolute value because everything's going to be in the first quadrant. Cosine's always positive. And then from here, what I wanted to do is a use substitution, but it's not really set up very well for it. So what I want to do instead is let's multiply the denominator just by the conjugate. So what I'll do is I'll multiply in here by 1 minus cosine t, and then we want to multiply by the same thing here in the numerator. So when we do that, I'm actually not going to distribute everything in. I'll keep the numerator the same and just multiply in this. But then when we distribute out the denominator, we're going to get 1 minus cosine squared t. That's going to be the same thing as sine squared t. So let's just write this in as sine squared of t. But then sine squareds cancel here and here. And what we're left with is going to be pretty easy to deal with. We're going to have just cosine of t minus cosine squared t. Cosine t I can just integrate. So we'll integrate this one to sine of t evaluated from 0 to pi over 2. And then on cosine squared, I'm going to want to use an identity on that. So what I want to do for the power reduction on this, the formula is going to be 1/2 1 minus cosine 2t. That's going to be the same thing as our cosine squared. So when I write this in over here, I'll take the 1/2 out front as a constant, and we're just integrating 1 minus cosine of 2t dt. And now I think we're about ready to finish it. So first evaluating sine at pi over 2 is just 1. Sine at 0 is nothing, so we'll leave that off. We've got this minus 1/2 here. First integrating 1, that's just going to be a t evaluated from 0 to pi over 2. And actually, let me just combine all this together. I don't think there's any reason to evaluate this separately. So we have our t. Then for this one, the integral of this is going to be sine 2t. And then we just need to bring a 2 out here as a 1/2 and evaluate from 0 to pi over 2. So evaluating this, we have our 1/2 factored out. This first part plugging in pi over 2, we'll just have pi over 2 here. When you plug pi over 2 in here, sine of 2 times pi over 2, that's the sine of pi. That's just going to give me a 0 right there. And then for the second part, we plug 0 in for t. That's just a 0. Sine at 0 is 0, so this whole second part is just going away. This here is nothing. We just need to distribute in the minus 1/2. And so for my final solution of this, we just get 1 minus pi over 4. Okay, method number 2. This time we'll skip the trig substitution, skip any substitution really, I think, and we're just going to multiply in the conjugate of the denominator. But so we're not changing it, of course. We'll do the same in the numerator. Then let's just multiply everything out. I'm going to leave the numerator the way it is, so we'll just leave it and just write everything in. Then for the denominator, first we get 1 squared, which is just 1. Then we're going to have minus. When you square the square root, we're just going to get back what's inside, so 1 minus x squared. But then what happens here, the 1's are going to cancel out and be a 0. Distribute the minus sign in, minus times minus is plus. Now we just have an x squared here in the denominator. X squareds cancel, and now we just need to integrate this thing. But now here we can split this in 2 integrals. We're just integrating 1 here, so we might as well just do it. Integral here of 1 is going to be x evaluated from 0 to 1 minus this integral right here. But now this right here may look familiar to you. We can just if you kind of rearrange this really quick, if you like set this equal to y and then you square both sides, you have y squared. I'm not going to worry about the signs or the absolute value. We're just going from 1 to 0. So just let's do it out real quick like this. So you square both sides, you get this, rearrange it, and what you have is x squared plus y squared equals 1, which is just an equation for a circle. And so now we just have a rough sketch of a circle. In this equation, it's like this is 1 squared, so this is our radius right here. So we're saying we have a circle with radius 1, and we have our equation for the area of the circle. Doing that really quick, this area is going to just be pi when r equals 1. But we don't actually want the area of the whole circle. First of all, our bounds are going from 0 to 1. So if we view this as 1 right here, we're only looking at the right side. And then the square root of 1 minus x squared, it only returns these positive values. So really what we want is just 1/4 of our circle. So this integral here, this value is going to be just that first quadrant, and that area is going to be just pi over 4. So putting it together, when we just evaluate this first part, we're going to have 1 minus this, which is pi over 4, and that's it. Okay, there you have it. Good one today from Berkeley Math Tournament 2023. Thanks everyone for watching. Have a good day.